are moving on to chapter 54. And so, we have talked about organisms, populations, communities, and now we're going to be talking about their ecosystems. So, as we get larger and larger, so we are now talking everything within there. We're really going to focus on what limits production in the ecosystem, how nutrients move in an ecosystem, and how energy moves throughout the ecosystem. So, an ecosystem is all organisms in a community plus those abiotic factors, rain, sun, all of those. So this is its own little ecosystem, this terrarium. Also, then the ecosystems transform energy, process matter. Energy flows chemical matter cycles. They are self-sustaining. So what do you need? You have to get the energy, transfer the energy, and cycle those nutrients. And again, self-sustaining. So you can think of an aquarium, terrarium, you can see there is little organisms in here. So what brings everything in? Again, those nutrients are cycling. You don't get rid of them. You can't create or destroy this matter. The energy is going to flow through. It's starting with the sun, going through. So first, the sun, the producers, which are the plants, get energy from the sun. Next, and so some of that energy is released. Next, we go to the primary consumers, who are herbivores, and we lose some energy. Next up, we have our secondary consumers, or carnivores, and we lose some energy. And we could have tertiary and quaternary ones as well. So energy is always going to flow through. It enters as light, exits as heat. And so this is the same as the last one, where it's going primary, secondary, tertiary. Also, that energy is going into detritus, which microorganisms and other ones can consume. And so in the blue, we have all our chemicals that are going through. So think of all your cycles. We have the phosphorus, the carbon, water, and nitrogen cycles. Everything's flowing through. It's all in us. And then we have the energy flow. So as you get eaten, energy is flowing, and we lose energy as heat. Every organism does. So we have our food chain. So that's just one eating another, which all goes into the trophic levels, which is their feeding relationship. So level 1 down here we have producers. All starts from the sun, like I've said. It's captured by the plants, which are the first level of all food chains. We have to have plants, otherwise none of us have food. And so the food chains usually only go up 4 or 5 levels, because after that they're going to run out of energy. You get only 10% of energy each time you go up. So primary, secondary, it's our carnivore, tertiary, who's our top carnivore. All levels connect to the decomposers. And so both these guys could be autotrophs, so they are producing their own food, versus heterotroph, those who eat other foods. There's the sun, giving us all our energy. This is kind of the same piece, but so abiotic reservoir, you could think of water, temperature, whatever. Nutrients enter in, go to the producer, the consumer, decomposers. Everything is cycling around. And most importantly, decomposition connects all trophic levels. It eats everything. It doesn't care if it's a plant or a lion. It eats everything and brings those nutrients back in. So again, the nitrogen, carbon, etc. The food web really just takes that food chain onto a whole new level. So here's a nice little food chain right here. The food web, the leopard seal doesn't just eat fish. It's bird, squid. It wants to eat. And so it's all linked together. Who eats whom? And so it can go into one or more than one level. And so if you have a bear, he could eat fruit or he could eat meat. Humans, you may only eat plants. You might eat, so if we ate this whale here, right now we are ate the phytoplankton. So here's our producer, primary consumer, secondary, tertiary. So we're tertiary right there. But if you go over to this, on this side, here again is our producer, primary consumer, secondary consumer, tertiary, quaternary. So we could be quaternary. So depending on where we're at, we can change places. So there is a way to calculate all of this, the gross and net primary production, and so we can take that ecosystem's gross primary production, which really usually comes by biomass, dried plants and animals, and the net, which is the gross primary production minus the energy used. And so only the net is available to consumers. So that's the 10% rule, only 10% was on. Overall, terrestrial, so land, contributes to 2/3 of the global net primary production. And marine ecosystems, only 1/3. And so this is kind of trying to show you the more colorful is where you're going to get a lot of that energy from. So, nutrient limitations. Obviously, the more nutrients you have, the more you're going to grow. So one of the major ones is light. But besides light, nutrients are also going to limit that primary production. So you think plants, well, really all they need is light. Well, that fertilizer adds in that nitrogen and phosphorus. So limiting nutrient is the element that must be added. So whatever is being limited, that's what it needs. In order for production to increase, you need to add that nutrient. And again, nitrogen and phosphorus are typically the nutrients that are most often limit marine production and even plants. This is an experiment which phytoplankton, which is in the ocean and is an autotroph, so it's producing its own food. You can see here, show this for good, but we have the amount of phosphorus, and as phosphorus increases, the phytoplankton increases. And so showing different amount, and in here it shows ammonia and the phytoplankton kind of respond. Here's also, you can see if they have nitrogen and phosphorus and other metals, they increase quite a bit. So iron can also be limiting. Now here's that inefficiency of energy transfer, which is the loss of energy between levels of food. So this bug here, he's eating it. Part of his energy goes to growth, part of it goes to cell respiration, a lot of it goes to waste. And so that's just daily living things. And if you're going to move on, do in there. So that energy lost is just us being able to move around, move. And here you can see that only 10% of that energy is on. And so each time we go up the food chain, we can feed fewer animals. And so, and this is that 10% loss. So, depending on if you're a vegetarian or a meat eater, you are going to take more energy to eat because we get less energy from a cow than we do from corn. So, again, we have our inputs, we have energy and nutrients. Energy is flowing through, nutrients are cycling. So, don't forget, matter cannot be created or destroyed. Nutrients can only cycle, you can't get rid of them. And again, energy is going to flow through. Here is just a general what's happening. And so you have things alive, detritus eating it up, it's fossilized, so we have our fossil fuels, we burn them, it goes up the atmosphere, it can go into the rocks, or it can go back into like soil and plants. Right. Carbon cycle. Every living thing is made of carbon. The water can also dissolve carbon. We have our fossil fuels, which are just dead plants and animals, mostly plants. When we burn those, we put it back up in the atmosphere. It comes out of the atmosphere through photosynthesis, also goes back up from respiration and from the ocean. And so, here's some major players. Photosynthesis, again, takes it out. Respiration puts it in. So, one of the reservoirs where it stays is in the atmosphere, carbon dioxide. It enters it through photosynthesis, the carbon fixation in the Calvin cycle. Recycles throughout everything, returns to the abiotic through respiration and combustion. The nitrogen cycle, I am actually going to continue this on part 2 so that we don't run out of time.